Hello everybody, I want to finish out the review for you. There are just a few problems to do, but I want to take some time on a few of them because there's some interesting ideas here. 27 says the area of a tennis court is 5,280 square feet and find the length if it is 48 feet wide. Okay, so here's what we have. We have a rectangle that contains 5,280 square feet. They give us a width of 48 feet. And our job is to find the length. So we ask ourselves, how do I find the area of a rectangle? Recall that the area of a rectangle asks you to multiply the length times the width. Well, we have the area and we're missing the length, so we're going to have to go backwards from multiplication. Backwards from multiplication is division. And so really our job is 5,280 divided by 48. I'm getting 110. And that's all you got to do. Because if I do 48 times 110, I'm going to check it out here. Here's the calculator you're not allowed to use. 48 times 110. There we go. So we must be right. Cool? So that's 27. Let's go to 29. On 29, it says to solve for R if you are given that formula. Okay, so here we have that, and we want to have R. It says solve for R. Solve for R. All right, so let's check where R is embedded right there in the midst of some multiplying. Working backwards from multiplying means I'm dividing. So I'm simply going to divide out everything that's not an R to both sides. We don't want to break any math laws. So this looks really funky, but it's not that big of a deal. Nothing will divide out. It's just nothing you can do with it. You just end up with C divided by 2 pi, and that's all you can do. And then recall that anything divided by itself is a 1, so I have 1 R there. So when we solve for R, we get C divided by 2 pi. That's literally all we can do. 31 is asking us to solve for W this time. Solve for W. And it's that area formula that we worked with before. Oh, see, we kind of already did that, didn't we? So if I find W, it's embedded in some multiplication. Oh, you know what I would like to do? I'm going to save 31 and 32 for you because I'm looking at 30 and it has addition subtraction in it, and I want to work with that for you. All right, let's go to 30. 30 wants us to solve for x. And this is some crazy made-up formula. 2p equals kx minus q. Okay, here we go. Oh boy, all right, so now we find here's x. X is stuck with that k by multiplication, and it's also stuck with this q by subtracting. All right, so I'm going to start the same way I would if this all had numbers, and that would be by adding, getting rid of the adding and subtracting first. Now, there are no like terms here, so here's the best I can do on this side. Okay, getting closer, x. X is now stuck by multiplication, so we're simply going to divide. And your answer is going to look so strange, but it's going to be so correct. Now I'm just going to come over this way. So right here, I've got no like terms, nothing I can really divide out. I'm just going to leave that just like it is. And then here on the other side, check it out. K divided by K is 1. And so this is your answer. I think that's neat. All righty. Now I'm going to erase and go to the remainder of this. 33. Okay, 33. Negative 6 is less than c plus 3, which is less than 2. Now our job is to solve and then write the solution in interval notation. Okay, so we're going to solve this way. You want, look, this, just like most everything else in algebra, this looks way more strange than it start just by doing this. You want to end up almost like an equation where you just have the 1c all alone. So that gives me now that negative 9 is less than c less than negative 1. Okay, so here's the solve part. We've solved. All right, so let's go to the graph part. The graph is going to look like this. Now, on this number line, whether you see them or not, it contains all the real numbers. It contains everything. I'm not going to write all the real numbers. I'm just going to write the ones that I need. Well, I need negative 9. I need negative 1. And now let's see what's going to happen here as far as which intervals apply. Okay, so negative 9 is less than c. Well, that means that c is greater. All these unknowns, these are the guys we don't know. These are all of our possible values. All of these c's are bigger than negative 9. So that means that there are all of these. These are all the c's that are bigger than negative 9, all the ones that go this way, right? Okay. Then, but oh, not including negative 9 though. That's important. Only the ones that are bigger than. So I'm going to need an open circle there. These c's are also less than negative 1. So that's these. They start at negative 1 and go this way. Alrighty. So look what's happening. We need the values that do both. They're both bigger than negative 9 and less than 1. Well, the ones that do both are those. So your final graph really is from negative 9 to negative 1 with those two excluded. That's really what your graph looks like. Makes sense? Because it's these values right in there where the overlap is. So there's our graph. And now the interval notation. Here's what's important to know. Brackets, if you have this, that means that your value is included, which would mean closed in circles between the negative 9 and negative 1. That's not what we have here. We have this. It means that those values are excluded. So that's what we have here. Oh, that's not even open. All right. So let's get to the interval notation part of the solution. You're going to have, we don't include negative 9. Then we go to negative 1, and we also do not include negative 1. That's the interval notation. That's my dog coming back. Alrighty. So these solutions involve 3 parts. Yes, we love you, don't we, Ribby? Involve 3 parts. Solving, graphing, and the interval notation. Now I want to be a little clearer about what your final graph really will look like here, because I've got 2 things here and I don't want you to be confused. So here's what it's really your graph would look like. I'm going to have your number line from negative 9 to negative 1. It's this, and that. That's your final graph on that one. Alrighty. Let's go to 35. on 35. All right, another important concept embedded in here. We're going to solve by dividing by -5. This is going to give me B, is going to give me a -5. But what about, is your solution greater than or is it less than? Okay, I'm going to have to preach a little bit, so I'm going to keep that open for a second. So if we let's leave the let's leave it less than or equal to -5. Let's just leave it that way for a second. And so let's think about numbers that are less than or equal to -5. Well, -5 is less than or equal to -5, -6, -10. Let's just hang on to those. Now let's take these, just like we learned before, we should be able to plug these right back into there and get a true statement. So let's see if we do. Let's go -5 times, let's try that one. -5 is less than or equal to 25. So we get that 25 is less than or equal to 25. Okay, well that's pretty good. That's okay for right there. But what about, let's try -6. -5 times -6 is less than or equal to 25. This gives me 30 is less than or equal to 25. Oh my. Suddenly we start going off the rails here. That's not working anymore. Let's try this -10. It's also here, less than or equal to -5. Let's see if it'll work. -5 times -10, less than or equal to 25. Well, that's 50, which is certainly not less than or equal to 25. So, oh my, we've got a problem here. Here's the fix. And you only have to do this when you are multiplying or dividing by a negative with an inequality. So your solutions are not less than or equal to -5. They actually have to be greater than or equal to -5 in order to make the solution true. Alrighty, so don't forget, and this is why, this is what happened when we kept our sign the same. Even though we divided by the negative, messed up our solution set. So we just make sure we flip that sign over, then it gives me values bigger than or equal to -5, and we're okay. Alrighty, so we're supposed to solve. We're supposed to graph. Let me move this out of the way so that we can graph. Once again, there's my number line that automatically contains all the real numbers in the world. I don't have to write them all. I just know they're there. If I just have one value, I like to start with 0. So we'll put 0 here, -5 down here somewhere, greater than or equal to. So since it's or equal to, that's like a half of an equal sign. Or equal to, and then all the ones that are greater than go this way. There's my graph. Here's your interval notation. -5 is included. And then this goes on to positive infinity. And positive infinity will always be excluded because you can travel as long as you want to, but you're never going to land on positive infinity. So there's 35. I have less than a minute left. I'll come back and do 37 and 39 on a different video.